Hello, everybody. This video is a quick review for your first comprehensive assignment in cost accounting. In this problem, I already have the solutions to a similar problem that you're going to have for your comprehensive assignment displayed. So it's not going to be a step-by-step procedure of how to do it, but it's going to help guide you through how you have to do it. And by that, I mean not every single calculation, but how the numbers flow through the different tasks that I'm asking you to do. In this example, we are will-fold wallets. We currently produce one product line of wallets, the Everyman. We want to expand our market share. We want to sell to new customers. So we're planning to launch a second, more expensive brand of wallets, which we're going to call the executive model. This new executive model is hand-stitched from leather. It's got microchips with built-in technology that blocks RFID signals so nobody can steal our information from our credit cards or little scanners that walk by us. It's a fancy model. We're going to assume the role of the production supervisor, and we're going to make estimates about the quantity of labor that's needed, and it's going to help us budget for what happened during the period. So the first step that you're going to have in here is you're going to have to make predictions about the quantity and of labor that you're going to need, and it's going to help you determine the cost later on. So in the first tab that you have here, we've got our two models. The Everyman we've been doing. Our employees have been producing these things. They've gotten pretty maximally efficient at these things. We're going to assume that the relationship between the number of units produced and how many hours it takes is relatively linear. Like we're going to assume that each wallet takes a certain amount of time, and therefore, based upon the time it takes to make each wallet, we can predict how much total labor hours we're going to need for any volume of production. And to do that, you're going to have to use the regression equation down here. Y hat equals A plus B times X. To get there, we need to figure out what our constant A and our slope B is. So you would do this by using the data analysis toolpack up here in the thing, just like you did on your chapter assignment here, to figure out what is the constant, the amount of hours we need hypothetically if we didn't make any units, plus the slope, how much additional time each unit is going to take. To put that in correctly, you got to determine what is your X value, which is your predictor or explanatory variable, and what is your Y value, the response variable. And X makes Y change. In the case of this example that we have here, the number of units that we produce is going to dictate how many hours it takes to finish. So units produced has to be our X. Labor hours would therefore be our Y. And we could go through and we could use the data analysis toolpack to use its regression function, and we would get info that looks a little something like this. And we would have our coefficient for our constant, and we would have our slope, our variable that we could use to determine how much extra time and additional units going to take us to produce. And with that, we can fill in those numbers. So those numbers right there are exactly the same as these two numbers that we have over here. Our constant and our slope. We can figure out the average amount of time, average amount of units we produce each month. You can see from my formula up here by taking the average of all of the 10 months of information that we have, figuring out on average how much did we use each month. And with all of that information, we can determine what our hours are going to be needed to produce that average volume of units by using our regression equation. This constant plus the slope times the average number of units that we produce gives us the labor hours that it took to make the amount of units are up above. And then to figure out what your average time per unit was, you simply take the amount of hours it took to produce, our Y, and divide it by X, the number of units that we produce on average during a month, and it gives us on average how long each unit took to produce. And we can use that in our predictions to budget, because now we have information in this example that says it takes us about 0.35 hours to make an Everyman wallet. That's our existing model. That thing has been made for a while. Like we are really good at doing that. But this new model that we're making, the executive model, it's brand new. And our employees got to get used to making this new model. Maybe it has different machinery. They got to get used to making different machines. They're going to get better as time progresses, which is a perfectly applicable time to use a time learning model, just like you did in that chapter. And for our time learning model given to you is the learning curve, how much we think production time is going to reduce to after we've doubled the amount of production that we have during the period. and our constant in this case, the amount of time it's going to take to make that very first unit. So we're saying it's going to take about 3/4 of an hour to produce the first unit. And every time our employees double the number of units that they've produced in their lifetime, they're going to decrease their speed down to, or decrease the time it takes to do this down to 96.37% of what it took before production doubled. With that, you can take your natural log of the learning curve, your natural log of 2, divide the log of the learning curve by the log of 2 to get your slope. And with your slope, you can throw it into this formula over here, where A is the amount of time that it takes to make the first unit, X is the cumulative number of units that you're looking for, and B is that slope. And with that, you can throw it in for the amount of numbers that are given to you over here to figure out what your cumulative average unit time is going to be for any volume of production. And then in total, what your cumulative labor hours will be to produce that amount. So here we got information for 200, 400, 600, 800, 1,000, so on, executive model wallets. Depending on what level we produce, we have a useful estimate over here of how much labor time it's going to take to produce that volume. But how many units are we going to produce? That's what the product mix is for. We are given, in this instance, the customer demand for each one of these units, which that's the max amount of time that we're going to, or the max amount of those units that we would produce. If we produce a unit beyond the 4,500 everyman or the 2,000s executive, we don't think we can sell it, and there's no point in making units that we can't sell. Well, let's use that information as well as our production requirements to figure out what's our optimal mix that we have. So what is the average amount of time that it takes to make an everyman? That is 0.35. We had it up here, so it's going to be whatever you had in your calculations. For our mix down here, we're going to need to figure out some form of an average amount of time per unit for this new model, the executive that we're making. You have a new model as well in yours. In this case, let's take the average time we get to if we made enough units to meet customer demand. We have 2,000 units as our customer demand. Well, if we go back to our predictions, we see at 2,000 units, the average time per unit is a half of an hour. So we can use that as our rate. That is our estimated amount of time it's going to take to make one of those models. With the information given here, we see that the contribution margin on the executive is higher than the contribution margin on the everyman. Convert that, turn it around over here to figure out not what contribution margin is per unit, but per the thing that we're constrained by, which is labor hours. You only have 2,400 hours of capacity. So we take 1 divided by the hours to produce each unit, and it gives us the number of units that we could produce per hour, multiply it by our margin per unit, and we get our margin per labor hour. And here we still see that the executive is the stronger of the two models. So we want to max out on production of the executive first, because that's how we're going to get the most profitability. Well, if we max out, what is maxing out? There's only customer demand for 2,000. So we should make 2,000 executive models, put that in our schedule before we even start contributing any time to the everyman. And to make 2,000 units, according to our predictions, it's going to take 1,000 cumulative total labor hours. So over here in our mix, we should dedicate that 1,000 hours to the executive. Since we only have 2,400 hours of capacity in total, that leaves 1,400 for the everyman. You multiply your margin by your unit of constraint, the labor hour, or you multiply the hours used by the contribution margin you would get per labor hour, and it gives you the total margin at full capacity from these products. And we have that information over here. And then down at the bottom, we can just flip things around. We allocated 1,400 labor hours to the everyman model. Well, our information says it takes about 2.86 hours. We can make about 2.86 everyman wallets per hour. So if we spend 1,400 hours making them at 2.86 per hour, that's 4,000 units of output we would have. It takes about half an hour to make an executive. Well, we just dedicated 1,000 hours to that particular model. So if we're spending 1,000 hours and we're making 2 of them per hour, because each one takes half an hour, that's 2,000 units we should be able to make with the time we allocated to the executive. So we have our 2 different levels of output right here, which we can budget for over on our direct labor budget. We have our required output, what we just determined we're planning to make down here. multiply by how long each one's going to expect to take, the same information we've been doing, giving us the total hours, which is going to match up with the amount that we attributed over here in our table to figure out what was our optimal mix. If we multiply that by what's given the $24 per hour hourly wage rate, we get the total amount of labor costs that are going to be incurred for this level of production respective to our two different models, and they're at 57,600. It's our best guess, but things don't always work according to plan. So on the last tab that you have over here, for calculations at least, you got to calculate some variances between what actually happened and what was expected. And to do so, you're going to use the same steps that you did when we did this chapter. What were your standards? They're what we expected before. We said back here in our predictions that we think every man wall we make is going to take about 0.35 hours. And given that we're going to make a ton of these and our employees are going to get better by the time we get done, the average time that it's going to take to make a executive wallet for the period is going to be about half an hour. So we can use that information along with our actuals over here to determine what our variances are. All the formulas are given in here, our actual quantity of labor used times our actual price. So here times here, we got all that, what we proposed in the beginning that it was going to cost, and our adjusted to actual and our flex budget, so on and so forth, will help us determine our variances. And we have our variances for the company during the period. Just as a note right here to make things easier, if you don't already, we have a favorable efficiency variance right here. And because it's favorable, it's good. So the easiest way to mark it and not have to mess around with using F's is go to the home tab and go to styles, and there's good and bad up here. So if you click on the cell that you want, it changes the color. Green's good, red's bad. That being said, we have just one favorable variance. Everything else that we have in here is unfavorable. It happens. Record your journal entries based upon your variances, which unfavorable variances, always a debit, favorable variances, always a credit. Whatever goes into WIP is going to be based upon your actual cost that you incurred, so on, so forth. We have all that information, but we realize right now at the end that something's off. Like we didn't hit what we were budgeting for. It happens. And when it happens, you got to come up with a plan to fix it. So the last thing that you have is a write-up. And in the write-up, talk about the appropriateness of the way. In this instance, I was talking about the way that we determine hours. Was our learning curve what we thought it was going to be on the predictions? Did we overestimate how fast our employees are going to get better? What kind of variance would that lead to? Is this a big enough information set to really determine that it takes 0.35 hours? And then even beyond the, how well your model is for determining what labor costs are going to be, what other factors could go into this? Why did we have such an unfavorable direct labor price variance? Was there a change in labor costs? Did some new law come in that increased the cost of labor for us? Was there something that happened with our union employees where they negotiated a raise that we did not foresee coming? Or did we simply have to put employees that make more money on this that we'd rather have making other products for us onto the everyman when they should have been the people working on the executives? It could be anything. So in the write-up, discuss whatever you feel from looking at your variances. Talk about how you made the prediction. Do you think that's the best way? Why these variances could be caused, and what you could do to rectify this so that next period, we don't have these variances. Things are closer in actual results to our prediction. One last thing over here. I filled in a cell when I gave you something to write in, which is super obnoxious because when you type into here, if you hit enter, it takes you out of the cell. And I know people like to write in paragraphs, etc. You can write me a big old wall of text if you want in this section, and I'm perfectly fine with that. But if not being able to write in different paragraphs bugs you, you can always insert your own text box. So if you go to insert, and then you go over to text box over here, you can draw a text box into the space, and you can write in it as you would like you're on Words. Test for paragraph 1, test for paragraph 2, etc. If you would prefer that, feel free to insert a text box and just leave it in the space right next to this one.